That's it. I hate children.
I'm done!
Hold up. Did you see how fast you were going back there? This is a no running school zone.
But police officer, I'm a material girl. Anyways, I wasn't even going that fast because I am the calculus teacher.
Actually, you were going P of t, t squared plus 4t, which is way over the school speed limit.
Well, what are you gonna do? Are you gonna arrest me? Are you going to make me solve Riemann sums?
I'm gonna take you to the Supreme Algorithmic Court. Hands behind your back.
Order in the court. Mr. Goldstein, the calculus teacher, has been accused of speeding in a 25 meters per second school zone. Going 4 meters per second is his initial speed. His movement is represented by this equation. Before we start the trial, let's take a look at some of Mr. Goldstein's previous crimes. Armed robbery, serial killing, calculus-related pickup lines, defamation of Camara's character, destruction of the mental health of students through forcible practice of calculus, math terrorism, arson, hating SpongeBob, Grand Theft Auto, 10 plus counts, and war crimes, 20 plus counts. What do you have to say for yourself, Mr. Goldstein?
I wasn't speeding, and I can prove it with calculus. Can you get these handcuffs off of me?
Fine, take this. But your argument better be good.
Let me explain a concept that you small brains in the jury might not be familiar with. P, V, A. Position, velocity, and acceleration respectively. And how we can use PVA to find out how they're related using the two core concepts of calculus, derivatives, or dx, and the integral, big F of x. A derivative, in simple words, is a rate of change or the slope of the tangent line to occur at a specific point. When one travels down the acronym PVA, you are taking the derivative. In other words, velocity is the derivative of position, and acceleration is the derivative of velocity. The integral is the opposite of the derivative. So the return to the original function before it was derived. When you travel up PVA, you are integrating. So position is the integral of velocity, and velocity is the integral of acceleration. To find my actual velocity when Officer Fuzz pulled me over, we must use PVA and take the derivative of the position function.
Objection. If you're so smart, why don't you prove this PVA concept?
Gladly.
I want more proof. Mr. Goldstein, you did PVA, but I wonder if you can find your velocity using your acceleration instead of your position. You did it forwards, but can you do it backwards?
Of course I can. That is what PVA is all about. This is integrating. Instead of finding the slope, we are doing the opposite, finding the area under my curve. My acceleration was 2 meters per second squared. When I integrate this function, given that my initial velocity was 4, I get the same exact answer when I took the derivative of position. I did it! Boom! Calculus.
Okay. I guess I made a mistake and I arrested you. You're finally not doing something illegal for once.
Yes, Mr. Goldstein, you've proved that you were going at a legal speed, so you can go free.
Speed? I think
Velocity is
what you mean. In fact, before I go free, let me tell you about a calculus concept called particle motion, because clearly you need a lesson in mathematics.
Objection. This is irrelevant.
Well, Velocity, also known as the rate of change of position or the derivative of position, or speed if you are an uneducated plebeian, is a vector. That means it is positive or negative depending on if you are going forward or backward. My velocity was positive since I was going forward.
Let's let the man say what he has to say about calculus.
Thank you. I'm sure you know what I'm getting at. If you have a velocity function and using PVA, you want to integrate to find its position. What if the velocity isn't positive the whole time? Then finding the total distance is impossible because you're going both forwards and backwards, so it's just confusing. Right? Wrong. If you integrate the absolute value of the velocity, you will get the total distance traveled. Well, if you integrate normally, you can only get the displacement, how far you ended up from where you started.
Mr. Goldstein, I was about to let you go free because you proved you weren't speeding, but this calculus jargon is too much for my brain to handle. Take him to the gulag.
The gulag? No!
Get back in your handcuffs.
Yes, I am hopeful for today. Take this music and use it. Let it take you away.